here is the graph of x equals y to the 5/4. This curve that turned red up here. Here's the axis of revolution, the x-axis. And we're going to revolve this region about that axis of revolution using cylindrical shells. Okay, so our shells, when you use the shell method, are always parallel to the axis of revolution. So this blue strip is a typical shell. We're going to have infinitely many of them going from this 0 y coordinate to this 1 y coordinate. And the shell method, this is the formula, 2 pi times the definite integral from, in this case, 0 to 1 of the height of the shell, which is the length of this blue strip, an algebraic expression for the length of that blue strip. Since that's horizontal, it's the x-coordinate at the right minus the x-coordinate at the left, which is just y to the 5/4. And we have to multiply that by the average radius, which is the distance from the axis of revolution to the center of the shell. And this distance for each x is just y. So that's the distance from the axis of revolution at 0 up to here. And so there's your setup of the definite integral for this area, or for this volume. And you can see I set up the antiderivative, and I is 4/13 multiplied by 2 pi. There's your exact answer right there. Now I'll share my screen real quickly. Go to Desmos. You can see that as y goes from 0 to 1, the height of the shell is getting larger and larger, as is the average radius. And then I'll draw your attention to the fact that you could also do this problem using the washer method. If you solve for y in terms of x, you get the same graph over here, but now you can use the washer method. Pi times the outer radius squared minus the inner radius squared gives you the same answer. Okay, there you go. Hope that helped clear up your confusion. If you have any questions, post a comment.